So the question that you asked me was about finding the squared residuals of these different lines. So in your problem, we have these data points, and this is just from your problem. It has your x and your y values and the corresponding x and y values that was given to us. You went and through and found the least squares regression line, which was y equals 1.9x plus 1.4, which looks like this line through the data points. The least squares regression line is one way to make a best fit line through the data. This line is the line whose square residuals have the smallest sum of than any other line in the data. Okay, if you were just to eyeball the data, you may have thought a line through the point -2, -2, and 2, 5, maybe the first and the last point would have been a good line. However, if you compare the squared residuals of that data to this least squares regression line, the least squares regression line's squared residuals would add up to be a smaller number. Okay, so I'm going to go through and I'm going to do the squared residuals for the best fit line through -2, -2, and 2, 5, which is not the least squares regression line. Okay, that line they gave to us was y equals 1.75x plus 1.5. So again, here's kind of a table that you can go through and you'll fill in these tables a little bit for yourself. Here's the x, which is again just the x data from up here. Here's the y, here's just the y data from up here. Okay, I'm going to call these lowercase y. However, I'm going to find my y hat, which is going to be what the y would have been had I plugged in this x value into this equation. So if I plugged in a -2 into this equation, I would have 1.75 times a -2 plus 1.5, and I would have gotten a -2. Okay, and I'm going to keep on doing that for each of my values. So here I plugged in -1 in for x, 0 in for x, 1 in for x, 2 in for x. These would be the points, my y values on a line that satisfies this equation. Okay. Then the residual is going to be the y from my data, my y, subtracted my y predicted from my equation. So my y minus my y hat. Okay, so we have a -2 here minus a -2, which is 0. Then I have a -1 minus a 0.25, which is a -0.75. 1 minus a 1 minus 1.5, which is a -0.5. 4 minus 3.25, which is 0.75. And 5 minus 5, which is 0. Okay, so this is just saying, okay, how far off, the residual is how far off is your predicted value y hat from your given value that was from your data y. Okay, so that means that if you had a 0 there, it meant that the point here, -2, is the exact same y value as on your data. Okay, which makes sense for this point here because we chose the going through the -2, -2 point. Okay. Similarly, here the y value is 5, which is what the other point we chose to go through, so that residual is 0. Okay. If your residual is negative, it meant that your data value is actually below the equation of this line. And if it's a positive, the data value is actually above that line. Okay. And I went through and I wrote that down here below this. Okay. Then we go through and do the squared residuals. So all we're going to do is take this residual and square it. So 0 squared is 0, -0.75 quantity squared is 0.5625, etc. Okay. Then to find the sum of the squared residuals, you just add up these values and you get a 1.375, and this is the answer for C. Okay, so when you go through and you do this for part D, you're going to have a different equation. You're not going to be using this equation that goes to -2, -2, and 2, 5. You're going to be using your least squares regression line. So you're going to go through and take 1.9 times your x value, which is -2, plus 1.4, and you're going to get some y value that would have been predicted from that equation. Okay, then you're going to find that y value and take it away from the y value from the data, and that'd be the residual. So you have to redo this column for part D, you have to redo this column for part D, and then you're going to add those together after you square them. So you will also have to redo this problem. This column also for part D. Okay, hopefully that makes sense, and good luck.